Alright, good afternoon. Sorry it took so long to get this on Moodle. It is a little bit delayed in time process for downloading this. Okay, so here we go. We're gonna go through graph analysis 7 step by step so that you can then repeat for graph analysis. Okay, so the first thing we're gonna do for problem number 1 is type it into our graph. So you have your home screen, select add graph, go ahead and type this in. Make sure that you're writing the exact equation as is. Okay, so originally my graph looks like this one right here, but it's difficult to see what there is. So if you then type on it or double click at this area right here, it'll become highlighted square and you can type in the values that you want. I chose 30, negative 30, negative 30, and 30. You could have chose different numbers, but the idea is that I want to be able to see the entire graph and I want to be able to visualize where these asymptotes are. So when we start analyzing our graph, we can find that information. Okay, so make sure that you do adjust your window so you can see as much as possible, or at least see the different inflections and changes in the graph. Okay, so this graph, it's a hyperbola. The next question is the intercepts. So we're going to use the graph trace function. So you select menu. The steps are to go to menu. After you hit menu, you're going to hit trace. And then after you select trace, you're going to hit graph trace. You're going to just be hitting the right arrow and the left arrow on your calculator in order to jump from the different sections of the graph here and also to get to those zeros. So the first part is that we know if we look at our first image when it was larger, there is no intercepts on this upper portion. So I hit the over button until I got to this portion, and that's where you see here. And if you keep on hitting over and over slowly, it'll stop at the 0, and this is your intercept. So this is what you need to put for your x-intercept, because this is where it's intercepting the x-axis. And then you can see here that for the y-intercept, it actually tells you it's the y-intercept, and this is the value. So that's what you should put in those two blocks. If we continue on, the next information it asks for is for the asymptotes. Okay, we kind of identified them on that first graph when we were looking. We saw that there is an asymptote here. And this is my vertical asymptote. Okay, in hyperbolas, your vertical asymptote is wherever the denominator is equal to 0, so you could also find it out algebraically. But we wanted to stick to our graphs, and looking at our graph, we'd be over here, and I'd be hitting the left arrow. And you can see as I hit the left arrow, I have 4.8. And then the next time I hit the left arrow, it jumps to this graph. And you can see here, now I'm at 5.1. So I know that there is no value at x equals 5, and that verifies for algebraically because we had over x minus 5, and x minus 5 cannot equal 0, and it doesn't equal 0 when x is equal to 5, so it can't equal 5, which is then our asymptote. So how would we write that into our document? Where it says asymptote, we would say, we would write vertical, and then we would write at x equals 5. But remember, we have a horizontal asymptote as well. It's a little bit more difficult to look at. So the vertical asymptote, we're looking at our picture, and we can just see from our graph that there's this vertical asymptote here. But what value is that? There's a couple ways you can do it. You can then go into graph trace like we did before, and just hit the over button until you get to a really large value, like 1,000. And what you're going to get to is really close to a number, and you're going to see as you get over and over and over, the number it gets closer and closer to is 3. And you can verify that again by going on to this side of the graph and doing the same thing until you get to a large number. And then you'll see that it also goes closer and closer to your y value of y equal to 3. You could also do this by using the table function and going into the table and typing a value like this into your table, and then it will show you what the y value is there when it pops out. So how would we write this in our chart? We would write a horizontal asymptote at the point y equals 3. Okay. So now it's asking for minimums and maximums. So if we look at our graph, right, minimums and maximums, there aren't any explicit minimums and maximums, so you would just leave that blank. Or you would put, like I said, a line through, so I know that there isn't anything there. Okay, so now we're gonna look at graphing for increasing and decreasing. And the way we look at increasing and decreasing is it's always as we're going along from left to right. What's going on with our x values as we go from left to right? So if we look here, as we come from the left, and we're really coming from negative infinity, and we're going this way, and we are continuing our function. If we trace along it, we would see our numbers get lower and lower and lower. So for our graph for increasing or decreasing, we still have to put this x asymptote on there because there is a point where it changes. So since the asymptote is at x equals 5, or no, it was 3, sorry. Yeah, x equals 5. Okay, so since it was there from negative infinity to 5, the function is decreasing. And then we look at it from our next part of our graph. Again, as we go from left to right on our x values, what happens to our y values? And our y values are also decreasing. So even though we have two portions of our graph, because of this asymptote here, we go ahead and have decreasing and decreasing for both parts of it. So then we write this in the function. We say that it's increasing. For where it says increasing, we're going to put a line because it's not. And for decreasing, we're going to write this as 2 intervals. So our first interval is from negative infinity to 5. And again, it's not equal to 5 because there's a hole there, or asymptote. And then 5 to infinity. And that's your intervals that you're going to write in the decreasing. Okay, next is the points of inflection. Remember, points of inflection are where you switch from concave up to concave down. Concave up is a U up, and concave down is a U down. Well, this doesn't have any U's down or up, so there is nothing. So you're going to go ahead and put your dashes in there. Okay, so now we're going to look at in behavior. What is in behavior? In behavior is when we're looking at what happens when x goes to a negative infinity. We already really looked at this because we looked at it not only when we were doing our asymptotes, right? We got to a really large value. So now as we go from x to infinity, what is happening to our y are our f of x, right? So in this case, we know that as we get larger, our values, as we zoom out, or if we trace along this way to larger and larger values and get closer and closer, further away, and larger x values, we know that our function then becomes closer to, but never reaches to our asymptote, which was at 3. Okay, so as we go to infinity, our function goes to 3. And the same thing, we do the same thing going to positive infinity, and because this has that horizontal asymptote, f of x also goes to 3 as we go to the right. All right, so let's look at our second problem. Oh, before we get there, domain and range. Domain is what our x values are doing, and we know that our x goes from negative infinity to positive infinity. Okay, so that's our domain. And then our range, same thing. Our range is going from negative infinity to infinity. All right. So now it says our intercepts. Again, we're just gonna use the graph trace function. You can see here, I have 1, 2, 3 zeros, and I have to write all of these values. So right here, this is the value that you're writing in the intercept, negative 2.50, negative 1, 0, and 3, 0. Okay, so y-intercept, same thing. I just did over until it highlighted that there's a y-intercept, and this is 0, negative 15. Okay, there are no asymptotes on this graph. Minimums and maximums. Even though this goes up to infinity and down to negative infinity, we have what's called local minimums and local maximums. So I can look at this graph and know that right here, I should have a local max or a maximum. And then right here, I should have a minimum as well, because it changes direction here. So in order to get those, you can just graph trace over them, or you can use your graph analyze. So you're gonna go to analyze graph, you're gonna choose maximum or minimum. You get this line and you click, you basically wanna make sure that you're to the left and to the right of where you think that maximum was. And then when you hit enter, there it shows up, it'll tell you there's a maximum, and this is the point that it's at. You repeat that process for the minimums, and you'll get a minimum. So you can see that it then stays on the graph. So this is my maximum that I would list, and this is my minimum that I would list. You could go ahead and estimate this to 1.5 if you want, or negative 1.75. But again, it's here information in the exact, so you can find that. All right, so now let's look at increasing and decreasing. So now that I have my minimums and maximums, these are the points that I'm going to put on my graph for increasing and decreasing. So I have, and I'm just gonna go, my x value is right from negative infinity to infinity. So my first x value where there's a point is at negative 1.81, and my next value is at 1.47. So now that I have that information, these are the different intervals that I'm looking at. I have 1, 2, 3 intervals. So the first interval is from negative infinity to my maximum. So I'm looking here and I'm saying, what is happening when I go from negative infinity up to my maximum? Here are my x values, and my function, my f of x, my y values are going up. So my function is increasing. And then I look from in between my maximum to my minimum and see what my function is doing with my y values, my f of x, and my y values are decreasing. And then lastly, I reach this point and I keep on going to the right, and my function, my f of x's, are increasing again. So there's your graph. So now I want to write these as intervals. So my function is increasing on these two intervals. So the first one is from a negative infinity to negative 1.81. I don't include this as a bound because at 1.81 it's neither increasing or decreasing. That's the maximum. Then I'm also increasing from 1.47 to infinity. Same thing, I'm not equal here because that is the minimum and it's neither increasing or decreasing there. So that's where my function is increasing, and then next I need to list an interval where it's decreasing, and that's from negative 1.81 to 1.47. All right, let's keep on going. We're going to look at our points of inflection. So this is a little bit more difficult. Points of inflection is where my graph changes from concave to concave up to concave down, or concave down to concave up. So if we look at this graph, we can definitely see that there is some concave features here. I can see that that gives me that U here and the U here. So it changes, or the point of inflection is somewhere in the middle here where it goes from concave down to concave up. So I'm using this on a CX. If you have a CAS, just like we went ahead and found the minimums and maximum, there's a feature there that says points of inflection, and you would just highlight between here and it'll tell you the exact point where it is. So we're going to use a little runaround, and that's by finding the derivative. So technically the derivative is where a function changes direction. You guys don't know how to solve for a derivative yet, but your calculator does. And we're gonna graph it, because we're gonna just stay here in the graphing. This button right here, d over d, there's a little box in the box. This is your derivative. So we're actually going to add this graph to our graph in order to see what we're looking at. So what I do is in my function part, I go ahead and select that d of, and where the first box was, I put x. Okay, so the first thing we're gonna put x, and then inside the parentheses, I copy my original function. Okay, so then I moved my f of my first function, I moved it to f of 2, and I made sure that both boxes are checked for f of 1 and f of 2, so you can see both graphs. So you just hit enter, and you'll get this, okay? So I have my f of 2 is my original function, and you can see here, it's the red, and it's the y function you had. And then this derivative function looks like a parabola. So where that point of inflection is, where it changes, is at my minimum. So I go ahead and do graph trace on this new graph, the derivative graph, and I find that minimum. You can see this is it right here, and that is my point of inflection. So again, to recap, in order to find your point of inflection, the first thing you're going to do is graph the derivative, which you think of as d over d box. You put x in there, and then you put your f of 1, your original function, in here. Then find the minimum. In other cases, there may be a time that you need to find the minimum or the maximum in case this graph was in another direction. If I had something like this as my graph, I would need to find the derivative right here, okay, and this would actually be a maximum, okay? So now you have your point of inflection that you put in there, and so we're going to go ahead and do our graph for concatenating, okay? So remember that point of inflection is the point that we're using to reference our graph. So I'm going to go ahead and we're looking at the x value, so we're going to say negative 0.167. Okay, so when is it concave up and concave down? So from negative infinity to negative 0.167, the graph looks like this, so it's concave down. And then from negative 0.167, it looks like this, so it's concave up. And then we can write these as an interval. So we have on here concave up first, so I have from negative 0.167 to positive infinity is my concave up. And then the next one is down, so it's the opposite. It goes from negative infinity to negative 0.167. All right, now we're going to look at our end behavior. End behavior is what happens as x goes to negative infinity to my y values or my f of x. So my function, as x goes to negative infinity, we can look here at our chart again, our graph, and this is as we're going this way, what happens to the function? The function goes larger and larger and larger, so we can go ahead and say goes to, in this case it's decreasing, so it's going to negative infinity. Then we look at the next section, as x goes to positive infinity, my function is increasing, so my function is with no limit, it's going to infinity. Lastly, our domain and range. This in behavior helps us with that. Okay, so our domain, just like our last one, is negative infinity to infinity. And my range, also there's no bounds, and this is going from negative infinity to infinity. Okay, that should be all the information you need. That should help you quite a bit. Have a happy Thanksgiving and enjoy your break. Those papers aren't due until Monday, so the 26th.